Welcome back to the IoT podcast. I'm your host, Tom White. Every week we are joined by the biggest names in IoT to unravel the trends, misconceptions and predictions for the Internet of Things. Before we get into today's episode, don't forget to subscribe on whichever platform you're watching or listening on and turn on that notification bell so you're never out of the loop. In today's episode, I'm joined by Jan Van Bruaene, VP of Engineering at RTI. We'll be discussing their software framework for autonomy and its impact on industrial IoT, including the concept of software-defined everything and the impact of various sectors, including automotive, healthcare and aerospace. We'll also get into the importance of data centricity and what that even means. Before we get into the episode, shout out to one of our sponsors today, 5E Tech. 5E Tech are specialists in finding people who make technology a force for good in the world. They bridge the gap between talent and deep tech businesses around the globe. Click the link in the description to find out more. Before we get into the episode, shout out to one of our sponsors, IoT Tech Expo Europe, the leading event for digital twins, IoT and digital transformation. Jan, welcome to the IoT podcast.
You're welcome.
It's great to have you on the show. Been looking forward to this since we had our discovery call and to learn a lot more about RTI. And I guess that's a great place to start as ever. So maybe you can give our viewers and listeners a bit of a background on yourself and how you got into the world of IoT.
Okay, very good. Well, I'm originally, maybe my name gives it away, I'm originally from Belgium. And most of my professional career I've actually spent in Silicon Valley. So about a week after I graduated in Belgium, I was on a plane to San Francisco, always working for companies related to communication. I worked at VLSI Technology. We worked on silicon for originally telco, but then gigabit Ethernet. We did the first gigabit Ethernet chip at VLSI. I worked at Sun Microsystems for several years, up and down with the .com, but it was also related to I/O. And then now for the last a little bit more than 15 years, I've been working for Real-Time Innovations, where I'm now the VP of Engineering.
Excellent. So just a week after you graduated, you moved to Silicon Valley?
Something about that, yeah. After,
wow.
It was sort of an exciting opportunity and it was the place to go.
It's a big move from Belgium, right?
It is.
Yeah. It's incredible. So obviously been in Silicon Valley for a number of years, been involved in telecommunications, joined RTI. Did you say it was 15 years ago, roughly, you joined RTI?
Yeah, 2006. I joined RTI from Sun Microsystems, which was a large company. RTI was much smaller then, but very exciting in the space of distributed real-time systems.
Yes, excellent. And I think that's going to be great to get into today to learn more about what RTI does. But as a sort of quick introduction, RTI as a business, what is the background of the company? Why did you join and why have you stayed for 15 years? You're obviously enjoying it.
Yeah. Right. So, RTI originally was started by robotic researchers out of Stanford, and they wanted to work on real-time embedded systems. The first product that they built was actually a tool to better understand how those systems work. So it was called Scope Tools. And then from then on, we built a communications platform that takes care of the entire communication between the real-time distributed systems. So what we do at RTI, what we enable are systems, are smart machines such as a CT scanner. So if you look at sort of the CT scanner, you pull away the nice packaging or the nice system. There's a huge advanced system there. Right? So smart machines, intelligent systems like hydroelectric dams, those are incredible systems out there, or even patient monitoring systems in hospitals. Those are quite evolved. And then anything that looks like a robot, flying robots, medical robots, robots on wheels, so like autonomous vehicles. That's what RTI has been focused on for several years. And it's a very interesting space. 15 years ago, the applications were much different than what we're seeing right now. So why am I still at RTI is exactly that. The type of stuff that we are seeing working with our customers. We're no longer a small company. Our software is used in over 1,800 designs, 250 autonomous systems. Even the technology is part of many different standards. So we're sort of really at the cusp of seeing how all those systems make a world run smarter, healthier, safer. So that's sort of pretty exciting place to be.
Yeah, I mean, thank you for that. I mean, what struck me in our discovery call that we had was just how many businesses the software is used in so many different industries as well. I mean, it's really quite impressive. I mean, some of them you can talk about, and some of them obviously you can't. But RTI has a foothold across a range of different industries, hasn't it? And it's very, very impressive.
Correct. I mean, we are originally a lot of our initial customers were more aerospace and defense based, and that's still a huge part of our business today. And that whole industry keeps evolving, building more complex systems, etc. But since then, we also moved into areas such as medical systems, quite a few. Automotive is a huge area for us, especially recently. A lot of advancements there. Energy, industrial automation. So we have a software technology that can benefit all of those industries because they all have very similar characteristics, sort of the problems that they're trying to solve.
Yes, yeah, absolutely. And I think one of the things that we wanted to talk about today was a little bit more around, well, there's a few things, but the industrial side of what you're doing. So IoT is a big industry, and the whole industry 4.0 movement into industrial automation and the change of the warehouse really from what it was 50 years ago to what it is today. Could you talk a little bit about some of the work that your business is doing in industrial automation and what that landscape looks like today compared to, say, 5-10 years ago?
Right. So when we talk about, I mean, people ask like, what does RTI do in the IoT space? And you of all people know this very well. IoT means so many different things to different people. So at one side, we're sort of like, well, what we define is we work in the IIoT, industrial IoT, as opposed to the consumer world. A consumer IoT is sort of Nest thermostats, smart door locks, cameras. The other side, industrial IoT, is really not about devices, but about big systems. And sometimes the word industrial, it does mean sort of manufacturing floors, things like that. But it also means medical, it means automotive, it means large systems that are much more complex than connecting a device to the internet, right? And both are really interesting places. But what we have a technology that is really focused on is the second part, is how do you deal with those environments where reliability is huge. Like if let's say your hydroelectric dam has a problem, that people will notice, right? Or if in an operating room, all of a sudden some of the systems start misbehaving, that has huge consequences. Same thing in automotive. If you're all of a sudden on the freeway and part of your system doesn't work, huge impact of that, right? So reliability is huge for us. Also, the real time, where if you're sort of like, what does real time mean for us? We're looking at milliseconds, microseconds type of applications. And then we're dealing with complex data flows. Just to contrast, I'm sure that the Nest thermostat is a pretty advanced device, but the amount of data that it probably controls is quite limited. Sort of temperature, maybe some logging information, etc. When you look at what happens in an operating room in a hospital, there's all kind of data. Some of it is much more important, like checking that the heartbeat is still there. You don't want to have a glitch there, but maybe some more like video information. What is actually the scope doing? Those are different types of data with different types of characteristics. So if you sort of look at systems, reliability, real time, and then complex data flows, that's the space that we play in. That's what we call the industrial Internet of Things. Which spans all of these different industries because they all have very similar needs.
I think you've explained that incredibly well. Yeah, I think sometimes people, when they look at IoT, they see it from a consumer electronics point of view mostly, right, rather than the entire landscape, which can mean a lot of different things. And I think that real-time aspect there is very poignant, isn't it? Right, real-time systems, embedded systems, for events occurring there and then is a major aspect of this. Yeah. So it's interesting to know that a little bit more around RTI's kind of background, where it's getting involved, and especially from an industrial setting. One thing I'm really keen to talk on is something that we spoke about earlier, which is software-defined everything, which is a great concept. In previous podcasts, and our viewers and listeners will remember, we've had people talking about software-defined cars, software-defined networking, but you spoke about this going further in the fact that everything is going to become software-defined very, very soon. Could you explain that to people that perhaps don't understand software-defined as a movement and why it's so important?
Right. Well, so we see this if you look at the different industries that we're in, we see sort of the similar trends pop up everywhere, where the move towards more advanced systems, software-defined systems, that we saw this in the aerospace world, but we see this in medical world and automotive world, where instead of having just point systems doing one thing, and there's quite a bit of software in a car already today, or the car from 5 years or 10 years ago, but now people want to actually, partly driven by more capable silicon, more capable systems, they're saying, instead of having all these point systems, we can actually bring that together, right? So, and then if you actually then even push it even further, now your entire car, most of it will be driven by one or two large compute engines that will actually take care of the entire operating part. So it has a lot of benefits in different industries. In the car industry, consolidating the number of components you have to manage towards one or two or three larger systems, and also adding more functionality. Nowadays, when you pull up in your driveway, you may get a message from your car saying, I have new software that I want to update, right? Whether it's over-the-air update or connecting to your Wi-Fi system. And as that happens, more and more capability can be added to the car, so that even if the hardware components there, maybe they're not enabled yet, but that actually comes a little bit over time. People add more capabilities. So we see that in automotive, but you see it in every industry where more and more smarter systems are being added, software developed systems that then can be evolved. Because one of the things that we also see is, especially in the industrial IoT space, we're dealing with real systems, hardware deployed systems. Updating those is not so easy, right? So if you sort of go and swap out a bunch of hardware, that's not an easy thing to do, right? Whereas maybe in the data center, okay, you put it, or on your laptop, you put a new operating system and you got the latest features, right? So, but when it comes down to those cyber physical systems, what they refer to, they put in a platform, and then the new capabilities will be rolled out with new software over time.
I think from an automotive perspective, you're right. It's the convergence of both EV and software defined for automobiles at the same time that's happening. But I think it's interesting because the threat now is not mechanical failure; it's software failure, isn't it? And what that looks like in the future. And I suppose that picks up on your earlier point about reliability from an industrial context. It's the same within cars, right?
Correct. So reliability, safety is also an important aspect there, so that making sure that the systems that you deploy can actually be used in a safe environment. We have applications both in automotive space for that, as well as actually in the aviation space. We leverage the same pedigree. Even in medical systems, the same thing. Reliability and safety are very, very important aspects of the platform that you develop.
And how I'm curious, as I'm sure some of our viewers and listeners would be, how can you, through software and presumably through testing and verification of the software, check the reliability of it? Is it just a multi-stage approach to try and break it, to see under theoretical circumstances how it might go wrong?
Correct. Well, there's a few aspects of that. So first of all, there's a lot of work that has been done in the area of safety, right? So whether it is avionics safety, most of these, if you look at these days, a lot of the airplanes are super safe, right? So there's a long history of developing those safe systems. It comes from a couple of areas. It comes from how you handle requirements and how you actually test those requirements. So there's a very rigid approach to actually breaking down what you actually want to build and then how do you actually design it? How do you verify that design meets those requirements? How then you actually break it down to implementation and test that, right? So that there's a methodology of how to approach that. In addition to that, it's about testing and using the right testing tools, right? So it's a lot of the type of test that you're at, but also the level of validation that you build into your development process, whether it's static analysis, dynamic analysis, all kind of verification that you and capabilities that you add to validate that your software is actually well written. And then thirdly, having deployed systems that you actually run for a while also adds to reliability, because you learn along the way, right? So, and that's something that is also important. You see that in the automotive world, where people do put a lot of cars on the road just to go and see what happens over time with the right safety guards, right? So this is not just let's go test and see what happens. But having deployed systems over time that you can actually then have with the safeguards evolve is also another aspect of building a very reliable system. So,
yeah, I mean it's impressive, isn't it? The amount of work that must go into this behind the scenes before it makes it out there is fantastic. I mean, one of the other aspects of software defined that we spoke about is actually in healthcare as well, and we spoke about this case study of new medical robots and how software is helping for remote surgery. Could you explain how that is and what the future could hold with remote surgery through software defined robots and in healthcare?
Yeah, we saw. I mean, we're sort of in a very privileged position when we work with our customers to see what the advancements that they're building into healthcare. And maybe about 5 years ago, people were talking about alarm fatigue. How can we make sure that when an alarm goes off in the hospital, that we actually know that there's something wrong? Nowadays, people are talking about really robot-assisted surgery and then tele-operated surgery. Right? One of our recent customers, we just made an announcement last week. They're sort of doing two very complex systems. One is how can we make knee replacement safer? And they have sort of a lot of technology around that, using our products to build that, so that they do imaging up front and they know exactly how the robot helps the physician do the surgery safely. But then secondly, they actually just did a demo where the actual leading physician was actually 2,000 miles away. So they from New York, they were actually controlling the robot in Austin in their test lab where they were showing that, and basically doing that end to end using Connext, our software technology, is pretty impressive. Right? So they're doing both the real time connectivity over the WAN, and then in the hospital room as well, they actually enable their robot to do the right thing using our software. And you'll see more of those. I think that's sort of one of the areas that I'm pretty interested in the medical world is sort of the robot assisted surgery, right? Because I mean, surgeons are trained for so many years and there's so many things going on, but how can we make sure that they're helped in their craft and making sure that the right thing happens? That's where I think we'll see a lot more advances. And they need a good technology to do that. They need a real-time communication protocol to enable those robots to make it work.
Yeah, and I think again this example of reliability and literal real time is so important because you're performing surgery, so there can't be a delay, there can't be a lag. Presumably, one of the big benefits in this, Jan, and perhaps you can expand upon it a bit further, is the fact that the surgeon, say a particular surgeon specialised in the field, wouldn't actually need to be in the room. And so if you had a case, say, somewhere in Australia and you had somewhere, in Silicon Valley, you haven't got the issue of that person having to fly over, have jet lag, then feel in a better state to be able to perform the surgery.
Exactly.
So presumably that's one of the main advantages of robot-based surgery.
Correct. So that the specialist can be used in many different hospitals, and of course there's a local team as well, right?
Yes.
But they are actually work closely together. You'll see that both for the surgeons, but you also see that even for the nurses and the people who are actually monitoring the patients afterwards. it's one of the really cool applications. I mean, in the Bay Area here, there's always a shortage of nurses. And you hear stories, I mean, you read about them in the news where even nurses from let's say, other parts of the country fly here to work in hospitals, which is sort of crazy, right? Well, so on one side, you have the surgeons that can work remote, but you also see that the walls of hospitals are becoming less sort of defined by the building, where somebody who's monitoring how is the patient doing afterwards, they can tap into the information. What is the heart rate? How is the patient doing? What is all the signals from the patient? And they don't have to go into the room anymore. It used to be like, hey, let's go and see how Phoebe's doing, or what are the vitals of the patient. Now they actually can do that from the nurse's station, but even the nurse's station can be remote, so you can get sort of 24/7 monitoring of patients, and they don't even have to be in the same building. And that is also an application of connected medical world. So both patients, surgeons, as well as the nurses running and monitoring the patients.
Yeah. And I think if you look back at the pandemic days, COVID was a big issue in hospitals for contraction, right? So one would imagine if you're in that environment and you're having it done remotely or via robotics, you don't have that risk of cross-contamination and infection as well across different people, different fields, etc. It is fascinating. I wonder how far it will go in the future, right? And I know we'll get onto that later, so I won't get into it now. But I find it just incredible. Whenever it comes to inventions that will, enhance humanity, I think it's really, really quite impressive, actually. And it's great to know that you guys are working on software around that. And the other use case we wanted to talk about when software defined everything was in the aerospace sector. So you talk a little bit about that. You mentioned earlier briefly about aerospace and automotive, but how is RTI working in aerospace?
Thanks again for IoT Tech Expo Europe for sponsoring today's episode. IoT Tech Expo Europe brings together Europe's brightest minds to talk about cutting-edge technology in one place. Experience top-level discussions, innovative IoT innovations and strategies. Mark your calendars for the 26th and 27th of September 2023 when IoT Tech Expo Europe returns to the vibrant city of Amsterdam. I'll be there. Will you? Get your tickets at iottechexpo.com/Europe. The link will be in the description.
Right. So we have sort of two big fields there. We have aerospace and defense. If you just pure look at the aerospace field, several of the newer platforms, and some of them we can't name by name, but some of the newer advancements in sort of launch vehicles, they need. I mean, like one of the applications we can talk about is, for example, the launch control system for the Artemis launch that happened last year. It was a really important thing for many people at RTI. Had been working for years with NASA and many other to build such a system, and that's a very complex system. If you can imagine, when the rocket goes off, there's a very small window where a lot of things have to go right, and there's a lot of data that needs to be shared, and in the case that there's something goes wrong, they want to analyze it very quickly what is going on. Sometimes when there's a delay in the launch, they also want to know exactly, hey, what was the status of a particular system. So you need a very good real-time communication backbone to do that, and that's one of the areas that we're very good at. So they use some of our technology to make that happen. And then when the rocket gets launched, and some of the real exciting applications, when people want to control, let's say, space systems, rovers, remotely, now all of a sudden they have to sort of figure out, okay, how can we actually test that? How we can actually operate? So we have some of the experiments that were done where our software running on the International Space Station, controlling a rover first here on Earth at the Ames, so they can sort of test it out, and then eventually may go to any of the other Mars or other applications where they want to try it out. And there, just to contrast a little bit, we talked a little bit about medical robots, where you can imagine sort of the control loop being very tight, very a high frequency control to make sure that nothing, you have fast responsiveness of the device. You can't do that in space because you have a very limited bandwidth, and you have to be very careful how you use that. So how do you have a technology that can do both, right? So we have a lot of the capability built into our software, so you can work and you can control that rover, because there's a huge delay, right? And a large latency controlling some of those spaces. So aerospace, huge area for us, but also just in general, the defense market, U.S. Surface fleet from the Navy, for example, has many very advanced systems that rely on a technology like Connext to make them actually work well on their large ships.
Yeah, that's absolutely incredible. And again, testament to RTI's portfolio of different industries and different places to do business, right? And you mentioned there briefly Connext, and we're going to get into that now, to the different frameworks that RTI have. So could you start by explaining the framework? What is that framework? And then we can delve a bit deeper into it afterwards.
Okay, very good. So Connext is the family of products that we have, and they're all about giving the right data to the right place at the right time. As part of that, we have several individual products. Connext Professional is our sort of a big flagship product that is a toolbox of communication libraries. It has infrastructure services that help you build your big system, and also has debugging tools and operational monitoring tools. We have a secure, fine-grained secure version of that, Connext Secure. And then we also have other versions such as Small Footprint when you have resource-constrained environments, certified product for avionics and for automotive. And then for automotive, we have Connext Drive as a much bigger product offering that has also very tailored solutions such as to standards and capabilities in the automotive world. AutoSAR toolkit is one of the standards that are used there. So how do you actually make that work? And then we have another product called Connext TSS, which is focused on aviation systems. So that's sort of the product for offering that we provide. But there's a lot of components that go into that, right? So it's sort of maybe 5-6 products that I name here. But underneath there's a lot of libraries, a lot of capabilities to help people build their application so they don't have to worry anything about getting the right data to the right place at the right time.
So if a customer of RTI or a potential new customer wanted to acquire Connext or a certain component of Connext, it would be primarily around getting the right data at the right time and presumably as quickly as possible. And that framework of the different elements of Connext enable that to happen. And that's one of the main benefits as a backbone. So, and we've spoken a few different use cases in these industries, but there's an autonomous backbone to this, enabling AI as well, isn't there, Jan? Could you explain a little bit about that and some of the advancements that RTI are making? AI is hugely popular at the moment, generative AI, it's everywhere that you look. So that would be an interesting point to turn on this.
Right. So, which is true. If we're sort of often say we sit at the intersection of AI and pervasive networking, because what you need on one side you have sort of like ChatGPT, BART, Claude, all these large models that have been trained on big data centers for a while, right? So they often even like ChatGPT will tell you the recent events I haven't learned much about yet, right? So when you actually bring that and you want to do something in the real world, you cannot have, you need to have something that is actually very reactive, very responsive, because all of a sudden you want to learn, you want to observe something, you actually want to act, you want to make a decision, and you want to act on that, right? So of course, this is not about training. This is actually about running the algorithms, the AI algorithms at the edge. And for that, you need a mechanism to actually provide that data to those algorithms reliably and in real time. So they can actually work very quickly and make those decisions. Not to mention that also that a huge amount of in those systems, there's a lot of different data that you have to handle. So you need to be able to have a platform that is very good at providing handling the large scale of data, even to different consumers of that, right? So, and that is exactly what we do at RTI. We are experts at data distribution at scale, under performance to those systems, right? So if you want to, and that's what we see with in autonomous vehicle world. That's what we see even in aerospace world, where and sometimes it's even interesting to see the same application show up in different flavors over time. Processing a radar image, processing a LiDAR image. There's from a data distribution point of view, a lot of commonality in that. So we actually have been building that platform so that we can provide those AI models with the right data. Sometimes there's even also the aspect of connecting the edge to the cloud, because maybe some of the decisions or less critical decisions are maybe made post-processing afterwards. We actually have a very good an application where doing echography, where the one aspect is actually taking the image locally, but then the actual processing and seeing what actually was happening with the patient may be done offline or in a back-end system, so maybe not at the edge. In either case, you need to have a good, robust system that can provide that data when you need it, and even provide it to the cloud if that's part of the solution.
Yeah, thank you, Jan. Yeah, I think it's crucial, isn't it? And something that comes up so often in the podcast around the harvesting, understanding, and analysis of data, and how we've all been on a journey in this ecosystem to understand it and use it more, because IoT devices throw off so many million and trillion points of data. It's so important to be able to have a process around that. And we mentioned an interesting phrase, actually, which hasn't come up that often on the podcast, but is a really poignant one, and that is data centricity. Could you explain to the uninitiated what you mean by data centricity?
Right. So when we talk about Connext, we also refer to it as a real-time data bus. And that is a data-centric information sharing technology where the word, first of all, if you just look at the word data centricity as data is your first-class citizen that you deal with. What does that practically mean? So you have to sort of think in a distributed system, lots of applications, devices that need to share data. They look at it as sort of, instead of sending messages around that you then have to try to understand, parse, figure out actually what do you mean here, you actually think of it as a virtual data space that you update, read, and write to that data so that the state is always the same, easily available. So you don't have to actually have to go and try to understand from the messages. Data centricity, then once you actually know what the data model is and the data that you're dealing with, you can do some really advanced capabilities. Our infrastructure knows what type of data is being sent around, who's interested in that data, and actually can even do some really advanced filtering as well. So that we actually, and remember, the right data to the right place at the right time, you can't just send everything to everybody. So if you have an infrastructure that knows what type of data that you're dealing with, not some opaque message, and it says, oh, this application is actually interested in that data, they're subscribing to that data, because underneath the cover, there's a pub-sub mechanism that sends the data around, but in a very smart way. You can sort of look at some examples are, let's say you're interested in the position of cars near you, right? You can say, send me the position of the cars on the freeway. You don't want to hear from every car. You just want to know the ones that are close to you. So that advanced filtering capability is something that the infrastructure can provide with you. And then the third aspect of data centricity here, where if you know what data that you're dealing with, you can actually start putting rules on that. You can start putting what we call quality of service. You can basically say, well, that data is really important. I need to have it reliably. I can't miss even an alert, or I don't want to miss that at all. Whereas other data, where you periodically update it, you can say, well, if I miss one, I'll catch the next one, right? Or sometimes it's live data that historically, that sample from 5-6 seconds ago doesn't make a difference. But there's a lot of different quality parameters that you may want to control. Sometimes you may I don't want to be swamped by so many updates. Give me every 5th update. Well, if you now know what data that you're dealing with, you can actually start applying those rules. And that's what the infrastructure does. That's what all the the libraries and the lines of code that we implemented are actually handling, so that you, as an application writer, all you have to do is read, write, update the data. You don't have to actually know how it actually happens under the cover. Now, data centricity is not necessarily a new concept. A database itself is a data-centric technology, but that's for historic data in storage. We do that with a data bus for data in motion. Sort of the analogy is, and there's a lot of similarities you can draw between the two. The same way that you update a database, rows and columns and information. Now, think of that as position, alerts, the same way. And again, you're making it very easy of how to work with the data for the people who actually have to write the application.
Yeah, I mean, it's really impressive. And I think the framework, the platform, what you've built, and enabling people to carry on and focus on what they need to do, knowing that the data has a quality of service around it, as you say, is really important. Because without that QoS, it's difficult to reliably understand that it's in a good place, actually, because you're always going to have an eye on it and to check the quality and the quantity of that data. And I think that's really, really important. I want to get onto the future, actually. So I guess what does this all mean for the future? Where's it going? We've come on quite a journey so far. Where do you see it going in the next 5 years?
Right. We're already on that. We're already on the trend where we're going to see much more capable advanced systems, right? So, and it depends a little bit on the industry. Some industries are much faster on that trend already than others. I mean, of course, in the automotive world, people are talking about flying taxis in the news or sort of fully autonomous vehicles. That's pretty interesting. I think that's sort of the news grabbing headlines. I mean, wouldn't it be great if we sort of like the flying taxi lands in your driveway? I think you're going to see a lot more, maybe less sexy, but very important systems such as delivery of goods, trucking, mining equipment, where all of a sudden very hazardous environments, where all of a sudden a lot of these things are automated, safety matters there. And those things will all of a sudden fully be autonomous, right? Where yes, we're looking at sort of like the flying taxi, but underneath the cover, I think all of a sudden you have a lot of these systems that leverage the same sort of advancements, but actually will be here very quickly. That's automotive side. If you look at the medical side, we already mentioned a few of those advancements, right? Robotic assisted surgery, teleoperation, hospitals that are no longer defined by just one place, being able to discharge patients much sooner, provide them with some equipment so they can actually be at home with their family and still be monitored remotely, will have a huge impact, right? So even just elderly care that are remote, that you can actually monitor, see how things are going. A lot of these systems, I think, are going to change how we are dealing with providing good healthcare to patients. And then you'll see that in other industries as well. Energy, I think all of a sudden, connecting, although the energy sector sometimes moves a little bit slower because they're dealing with huge systems that are installed. But you're going to see a lot more of those alternative energy sources being integrated into the grid, and you're going to get sort of more of the smarter grid capabilities available. So we're already on that trend, and I think we're going to see more advanced systems coming out like that.
Yeah, it's going to be a fantastic time, and I have no doubt that you and your team are going to be at the forefront of a lot of this work. It's mightily impressive, some of the projects that RTI has been involved with. And again, a reason that you've been at the company for so long and in the esteemed position that you are now. Thank you so much for coming on to the IoT podcast show today. I've really enjoyed it, learning more about yourself and some of the innovations that RTI have been involved with. Where can people find out more about RTI, Jan?
So our website, rti.com, is the place to go. You'll find our blog. You'll find our links to our where we're on the social media as well. You can keep track of new updates from us, new releases, new capabilities that we're bringing out. So that's where the place to go, rti.com.
Fantastic. Jan, thank you once again.
It was my pleasure.
Thank you once again to IoT Tech Expo Europe for sponsoring today's episode. Once again, please get your tickets. The link will be in the description.
Thanks for tuning in to the IoT podcast. Don't forget to subscribe on whatever platform you're on. See you next week for more IoT talks and tales.